Hello grade 10 students. Today I am here to teach you chapter 22 in your textbook that's called rate. To discuss rate, we'll take an example. So we'll take two people, Sunil and Nimal. Sunil runs 40 meters within 8 seconds. Nimal runs 30 meters within 6 seconds. If you want to compare who runs fast, what we do? So we need to find out the distance traveled within 1 second. Now the distance is 40 meters for Sunil. 40 meters and he took 8 seconds for that. So what's the speed? Speed for Sunil, 40 divided by 8, you get 5 meters per second. If you take Nimal, he runs 30 meters within 6 seconds. 30 divided by 6, you get 5 meters per second. So when you take this ratio, what can you see? The speed of Sunil's and Nimal's both are the same. So who runs fast? We can't say that both are the same. If you take another person, Anil, if he runs 40 meters within 10 seconds, what can you say about Anil's speed? Anil, 40 meters within 10 seconds. So 40 divided by 10 is 4 meters per second. What can you say about Sunil, Nimal and Anil? Anil runs slowly compared to Sunil and Nimal. So today we are trying to learn about rates. Now, how can we find out speed? The distance traveled divided by the time taken. So, what's the definition of the speed? Distance traveled by a moving object in unit time. Within 1 second, what's the distance? Or 1 minute, the distance traveled. So unit time, within unit time. So when you take the units, you can take distance as meters and time as seconds. We use S. So we can write meters per second as the unit. Or if the distance traveled is in kilometers, what's the units we can use? We can use kilometers. I'll write here kilometers and hours. Hours we can use capital H. Then what's the unit? Kilometers per hour. So we need this formula to find out the speed. So we can't find speed when the distance is meters and time is in hours. So the standard units are meters with seconds and kilometers with hours. Now, what is uniform speed? Uniform speed is defined as the distance travelled by a moving object per unit time is constant. If always it is constant, we say the object moving in uniform speed. So this is important. The distance travelled by a moving object. Here, by a moving object per unit time is a constant. If it's a constant value, we say that's uniform speed. Now we'll take some examples. It says motorcycle is travelled 150 meters within 10 seconds. Find its speed. So what's the formula to find out the speed? Distance over time. So we can find out the speed using the formula. Distance travelled divided by the time taken. What can you say? Distance is 150 meters within 10 seconds. So when you simplify, you get 15 meters per second. This one, plane is travelled 240 meters within 8 seconds. Find its speed. So what's the formula? Speed is equal to distance over time. Here the distance is 240 meters and time is 8 seconds. Divide by 8, you get 30. So the answer is 30 meters per second. Now what happens in this question? Speed of a vehicle is given. Find the distance travelled by 12 seconds. Now we know the subject of the formula here is speed. But in this one, you need to find out the distance. So you have to make the distance as the subject of the formula. So we'll first do that. When you take speed equals distance over time, you can cross multiply here. If this is like 1. So what is distance when you cross multiply? Distance is equal to speed times time. So now we got another formula for distance. Distance is equal to speed times time. If you take the units, this is meters per second and this is seconds. So can you see? Minus 1 and 1 get cancelled out and you get the distance in meters. So the units for distance is in meters. Now we'll try to solve this. So what's the distance in this question? Distance is equal to speed into time. So speed is 32 meters per second and the time taken is 12. So multiply. 12 times 2, 24, 2 remaining, 12 times 3, 36 plus 2, 38, 384 meters. Now we'll take this one. It says speed of a vehicle is 50 meters per second. Find the time taken to travel 540 meters. Now we need to make time as the subject of the formula. Now when you take speed formula, you can cross multiply now. So here I can write speed times time is equal to distance. Now I want to find out time. What is time then? Time is equal to distance divide by speed. So what's the unit? Distance in meters. This is meters per second. Can you see? Meters get cancelled out. Then when you take s to the numerator, this is in seconds. Now we'll try to apply the formula. So this is the next formula. If we want time, make time as the subject of the formula. So here you need time here. Distance travelled is 540 meters and divide by 50 meters per second. So here when you divide, you get 1. So 10.8 seconds for this question. Now, how we can change the units? We know different units we can use for distance and time. So here meters per second, how can we convert to kilometers per hour? Or if the units given in kilometers per hour, how can we convert to meters per second? Now, which one is smaller unit? When you compare meters and kilometers, which one is smaller? Meters is smaller and kilometers is bigger. Now think about if you have a number and when you multiply by, I'll take something 10 and 3. What do you think? What will happen to this number? The numerator is bigger than the denominator. When you multiply by an improper fraction like that, the value becomes bigger. When you multiply the same number by 3/10, the denominator is now a bigger value than the numerator. So you get smaller value here. So we'll take that theory and see what's the ratio we need to multiply to get meters per seconds to kilometers per hour. Now we'll take kilometers per hour first. This means kilometer divided by hour. Kilometer and meter, what's the connection? 1000 meters for 1 kilometer. Then hours and seconds, what's the conversion? 60 seconds for 1 minute, 60 minutes for 1 hour. So we need to multiply 60 by 60 to convert to seconds. Twice you have to multiply. Now when you simplify, what you get? 0, 0, this 0 with this 0. 2 times 5, 2 times 3. So when you simplify, what you get? 5 and 80. The ratio between this to this is 5/18. So this is an important ratio if you want to convert meters per seconds to kilometers per hours or kilometers per hours to meters per second. You can think about this ratio. Now, which way we need to multiply to get this answer? I told you which one is bigger. Kilometers per hour is bigger value. So, if the ratio 18/5, you get a bigger answer. So, when you want to convert meters per second to kilometers per hour, we multiply it by 18/5. What about the other way? Smaller unit here. So, bigger unit to smaller unit, you multiply by other way round. So, 5/80. So, that's how you convert these units. So, remember that always this ratio you need to convert meters per second to kilometers per hour. Now we'll take some examples. So you have given 72 kilometers per hour, convert to meters per second. So what we do? 72 is the value needed and we need, this is a smaller unit. So what's the ratio? Smaller unit, so you take 5 over 18. So divide 6 times 3, 6 times 1, 6, 12 and 3 times 4. 4 times 5, 20. So what's the unit? 20 meters per second is same as 72 kilometers per hour. Now this one, kilometers per hour given. You are asked to convert to meters per second. Again, bigger to smaller unit. So what's the ratio? 180 multiplied by 5 over 18. 18 here 10, 10 times 5, 50 meters per second. Now this one, other way around. Smaller unit to bigger one. So what's the ratio? So 40, this should be 18 over 5. Then 5 times 8, 8 times 18. 144 kilometers per 1 hour. This one again smaller to bigger. What you do? We need bigger one in the numerator. 18 over 5. 5 times 1, 5. For 20, that's 4. 18 times 14. We'll multiply. 10 and 4. You get 252 kilometers per hour. Now, if you want to compare two speed values, what we do? We can't just compare these two because the units are different. So what we can do, you can convert one measurement to the other one and then look at which one is smaller or bigger. Then we can decide which speed is higher. Now we'll take 35 meters per second. We'll try to convert to kilometers per hour. So kilometers per hour, it's a bigger unit. Take 35, multiply by 18 over 5. 5 times 7, so 7 times 8, 56, 5 remaining, 7 times 1, 7, 7 plus 5, 12. 126 kilometers per hour. Now, this one is 126, the other one is 50. Both are in the same unit, so you can compare. So 126 is bigger than 50. So which speed is high? 35 meters per second is higher than 60, this one 50 kilometers per hour. If both are in same units, you can compare the speeds. Now we'll take this example. Speed of a motorcycle is 36 kilometers per hour. Find the distance traveled for 12 seconds. Now what's the problem? This is given in kilometers and hours, but you are asked to find out with seconds. So you can't just plug the values to the formula and get the answers. You have to convert the values. So the first thing you have to do, kilometers per hour, you have to convert to meters per second. So how you do? Take the value. This is smaller in size, so that means you are multiplying by 5 over 18. Remember this ratio, 5 and 18. So 18 times 2 times 5, 10. 10 meters per second. Now we can find out the distance. So what's the formula to find out the distance? When you make distance as the subject of the formula, that's equal to speed times time. Speed is now 10 meters per second and time is 12 seconds. When you multiply, you get the distance in meters. Now we look at example 1. A feather floating on air with uniform speed drifts 100 meters in 20 seconds. Calculate the speed with which the feather drifts. Speed with which it drifts, you can write down distance over time. What's the distance? 100 meters over 20 seconds. Now simplify, you get 5 meters per second. So that's the speed value. Example 2. Calculate the distance travelled in 1 minute by a bird that flies at a uniform speed of 5 meters per second. Here the speed is given in meters per second and this is given within 1 minute. Now the units are different. So 1 minute means how many seconds? 60 seconds. Now we want distance. What's the distance? Speed into time. Speed is 5 meters per second. What's the time? We have to convert to seconds first. 1 minute means 60 seconds. So 60 times 5. 300 meters is the answer. Example number 3. Calculate the time it takes for a car to travel 150 kilometers on a highway at a uniform speed of 60 kilometers per hour. So time taken, how can we find? Time taken formula is distance over speed now. Distance travelled is 150 kilometers and speed is 60 kilometers per hour. When you simplify, what you get? 6 times 2, 12. For 30, that's 5. 2.5 hours is the time taken. Example number 4. How far does a motorcycle travel along a main road in 5 seconds if its speedometer displays a constant speed of 36 kilometers per hour during this period? So you need how far. That means distance traveled. So distance is equal to speed into time. What's the speed? 36 kilometers per hour. And what's the time? 5 seconds. Can we apply 5 seconds there? No, the units are different. So what is the first step you have to do? Convert 36 kilometers per hour to meters per second. So what you do? Take 36. This is smaller unit, so you divide by 18 and multiply by 5. 18 times 2, 2 times 5, 10 meters per second. So we can use that value here. So we will use 10 as the speed and the time taken is 5 seconds. 10 times 5, 50 meters is the distance. Example number 5. How long does it take a train which is 75 meters long to pass a signpost if it is traveling at a uniform speed of 60 kilometers per hour? So pass the signpost means now the train is moving. Think about, this is the post, signpost. So the train is moving. So think about, this is the front side. So when it's moving like this, so here when it this way, this is not still passing. So the train needs to go here. The full length should be on the other side. So here, if this is 75-meter long train, that means from here, this distance should be 75 meters. So what's the uniform speed? 60 kilometers per hour. This is the distance of the length of the train is in meters, and this is in kilometers. So you have to first convert 60 kilometers per hour to meters per second. So what you do? Take 60 multiplied by 18 here, 5 in the numerator. 6 times 3, 6 times 10. So 50 divided by 3 is the speed in meters per second. Now you need to find out the time taken. The time is equal to distance divided by speed. We know the full length of the train is 75 meters. So 75 meters needs to go to pass the signpost. And what's the speed? 50 over 3. So we'll do other way around. 75 divide by 50 over 3, or you can convert to multiplication by taking the reciprocal. 3 over 50. Now simplify. What you get? 25 times 2, 25 times 3. 3 times 3, 9. 9 divided by 2, you get 4.5. So this is about time. So what's the unit? 4.5 seconds is the answer. Take example 6. Find the time it takes for a train of length 60 meters traveling at a uniform speed of 72 kilometers per hour to cross a bridge which is 100 meters long. Now, what it means? To pass this bridge, this full length should go up to here. So what's the total distance? So starting from here, this is the end point. So what's the total distance traveled? Total distance traveled is 100 plus 60. That's 160 meters. Then what's the speed? Speed is in kilometers. So the first step, we'll convert 72 kilometers per hour into meters per seconds. What you do? This is smaller, that means you divide by 18 and multiply by 5. You get 9 times 8, 9 times 2 and 2 times 4. 4 times 5, 20 meters per second. Now you can find out the time. Time is equal to distance traveled, that's 160 meters, with this speed 20 meters per second. So you get 8 seconds for this question. Now we'll slightly change the question here and see whether we can do this one. A train takes 11 seconds to pass street light post with speed 72 and takes 29 seconds to pass a bridge. Find the length of the bridge. Now what's given? It's given, if this is the light post, 11 seconds to pass the light post. So here 11 seconds. So starting from here, we say that this is the initial position, up to here you get 11 seconds. So here 11 seconds for this. Then it takes 29 seconds to pass a bridge. So passing the post as well as passing the bridge, 29 seconds. So that's the total time. So how can we find out the time taken? Time taken only to pass the bridge. That's the difference. So 29 minus 11. So what's the answer? You get 18 seconds only to pass the bridge. How can we find out the length of the bridge? So length is the distance. Distance is equal to speed into time. We know speed is 18 seconds and speed is 72 kilometers per hour. Convert to meters per second. So 72, when you convert to meters per second, you need to multiply by 5 and divide by 18 because meters per second is smaller. So you get 4 times 5, 20 meters per second. So substitute here 20. Then when you multiply by 2 first, you get 3, 6 and 0. So 360 meters is the length of the bridge. Now we'll try to find out what's the average speed. So average speed is defined as the total distance travelled divided by the time taken for travelling only. Time taken for travelling. Now why it's time taken for travelling? We'll take an example. Think about any object moves 10 meters within 5 seconds and the next 40 meters within 8 seconds. Then in this question, what's the total distance travelled? 40 plus 10, 50. And what's the time taken? 8 plus 5, 30. So this is moving here to here. But in another case, same problem you can give like this. 10 meters within 5 seconds and then taking a break. Half an hour break or 30 minutes break or 30 seconds, whatever, 30 minutes. 30 minutes break and then moving again 40 meters within 8 seconds. What do you think about the average speed? Do we take the whole time? This is 30 minutes means 30 times 60 seconds plus 5 plus 8 for the total time. We can't take the whole thing as the total time. So only when the object is traveling, we take that time. So here we can't take the resting time for the average speed. So remember that only total distance divided by the time taken for traveling. So here in this case also same thing, 5 plus 8 is the total time traveling and the distance traveled is 40 plus 10, 50. So that's how we find out the average speed. Example number 1. An intercity bus took half an hour to travel the first 25 kilometers of a journey. If it took the bus 1 hour to cover the remaining 80 kilometers of the journey, find the average speed of the bus. So first find the total distance traveled by the bus. So first 25 kilometers and later 80 kilometers. So the total distance traveled is 105 kilometers. Then total time taken for the journey. So first half an hour and then 1 hour. So half an hour plus 1 hour. So this is, we can write half plus 2 over 2. So 3 over 2 hours. Then how we can find out the average speed? Total distance divided by the time taken for traveling. 105 kilometers and the time is 3 over 2 hours. So what we do? You take 105 multiplied by the reciprocal. So you get 3 times 3, 9 and 5. 35 times 2, 70, and this is about average speed. Kilometers per hour. Exercise 22.1. Calculate the speed of an aircraft which flies 1200 kilometers in 4 hours with uniform speed. So, what's the formula? Speed is equal to distance over time. Distance is in kilometers, 1200 kilometers, and time is in hours. Now simplify, 4 times 3, you get 300 kilometers per hour. Question number 2. If a child runs 200 meters in 40 seconds at a uniform speed, find his speed in kilometers per hour. So this is the conversion. So what you do? First find the speed in meters per second. 200 divided by 40. 5 meters per second. Then the next step is to convert to kilometers per hour. So what is the ratio we take? Kilometers per hour is bigger value. So you take 18 in the numerator and 5 in the denominator. 5 get cancelled out. You get 18 kilometers per hour. Question number 3. On a certain day, an electric train moving at a uniform speed took 6 hours to travel a distance of 300 kilometers. On another day, the train took 8 hours to travel the same distance. Find the difference between the speeds at which the train traveled during the 2 days. So day 1, what's the speed? Speed is 300 kilometers within 6 hours. So when you simplify, you get 50 kilometers per 1 hour. The next day, day 2, what's the speed? The train took 8 hours for the same distance. So distance is 300 kilometers. So what's the value? 8 times 3, 24, 60, 8 times 7, 56. For 40, that's 5. Now they're asking what's the difference between the speeds. So difference is, you subtract 50 minus 37.5. So you get 12.5 kilometers per hour is the difference. Question number 4. How long will it take an aircraft which travels at a uniform speed of 300 kilometers per hour to fly 4,500 kilometers? Now they are asking about time. So what's the formula for time? Time is equal to distance over speed. Distance is given as 4,500 kilometers and speed is given 300 kilometers per hour. Simplify, you get 15. So 15 hours is the answer. Question number 5. Find the distance in meters that a car which travels at a uniform speed of 48 kilometers per hour covers during 30 seconds. So this is in seconds. So here first step is to convert kilometers per hour to meters per second. So what we do? What's the easiest way? Take 48. This is a smaller value. That means you have to divide by 18 and multiply by 5. And 6 times 8. Then 8 times 5, 40. 40 divided by 3. Now you can find the distance. What's the formula? Distance is equal to speed into time. Speed is 40 over 3. Time is 30 seconds. Then when you simplify, you get 400. What's the unit? This is in meters. So 400 meters is the answer. Question number 6. A bus travels for 15 minutes at a speed of 40 kilometers per hour and then it travels further 30 minutes at speed 70 kilometers per hour. Calculate the average speed of the bus. First 15 minutes, 40 kilometers per hour. Then the next 30 minutes, 70 kilometers per hour. You need to convert to the same units. So you are asked to find the average speed. So this is in hours and this is in minutes. Now first we need to convert this to minutes. Now here this is 40 kilometers per hour. How can we convert to minutes now? This 1 minutes. Hours you need to convert to minutes. 60 minutes. So I can write this one as 40 over 60. Now this is in minutes. This is in kilometers and this is in minutes. So 2/3 kilometers per 1 minute. What about the other one? 70. 70 kilometers within 1 minute. So within 70 kilometers within 1 hour. For 1 minute, this is 7/6 kilometers per 1 minute. Now we need to find out distance traveled here and here. So first we'll find out distance traveled this part. So speed is this one, 2/3, and time is 15 minutes. So you get 10 kilometers. What about the other part? For this part, what's the distance traveled? Distance traveled is, speed is 7/6 and within 30 minutes you get 35 kilometers. Now we know total distance traveled is the sum of these two. So we can write down average speed is total distance 10 and 35 divide by the total time taken for traveling. Total time is 30 plus 15. This is in minutes, this is in kilometers. So if you want to convert to hours, what you do? Here you get 45 and here 45 minutes. Simplify, you get 1 kilometer per 1 minute. If you want to convert to hours, what you do? 1 minute (1 kilometer). Then 1 minute means 60 seconds. 60 seconds, 1 kilometer, you can write 1000 meters. So you can answer the speed in meters per second. So 1 second means 1000 divided by 60. Simplify this, you get 6 times 1, 6. For 40, 6 times 6, 36. For 40, 6. So 16.6 recurring meters per second. Or you can convert to kilometers per second by taking this one as second. So we'll try to use other way around. 1 kilometer. How many hours? 1 minute means 1/60 hours. So 1 divided by 1/60 means 1 multiplied by 60/1. This is same as 60 kilometers per 1 hour. So you can answer the question in kilometers per hour or meters per second. Question number 7. If the time taken by a train to pass a signpost is 10 seconds, when it is travelling at a uniform speed of 54 kilometers per hour, find the length of the train. So here, if this is the signpost, so it takes 10 seconds. So here, we'll take this is the train. We don't know the length. So that's the distance travelled within 10 seconds. And the speed is given in kilometers per hour. So first thing, we'll convert to meters per second. So what we do? Take the value multiplied by 5 and divide by 18. So when you multiply by 3, you get 54. 3 times 5, 15 meters per second. Now, 15 meters per second is the speed of the train. So what's the length of the train. That's the distance traveled. That's equal to time into speed. Time is 10 seconds. Speed is 150 meters is the length of the train. Question number 8. Find the time it takes for a train of length 60 meters traveling at a speed of 72 kilometers per hour to pass a 100-meter long platform. So there's a 100-meter platform and the length of the train is 60 meters. Now to pass the platform, the total distance traveled should be this one. So total distance traveled, length of the train plus the length of the platform, 160 meters. What's the speed? Speed is in kilometers per hour. Convert the speed to meters per second. 72 multiplied by 5 and divide by 18. So 18 times 4, 4 times 5, 20 meters per second. Now, what's the time taken? Time taken is distance divided by speed. So, what's the distance? Total distance is 160 meters. The speed is 20 meters per second. When you simplify, you get 18 seconds for the time. So, what's the value? You get 8 seconds to pass the platform. Question number 9. A train leaves city A at 8 hours and travels at a uniform speed of 60 kilometers per hour towards city B. Now think about, this is city A and city B. A train leaves city A and travels this way. So starting at 8 o'clock in the morning, and the speed is 60 kilometers per hour. And another train leaves city B at the same instant, so 8 o'clock in the morning, and travels at a uniform speed of 40 kilometers per hour towards city A. If the distance between the two cities A and B is 100 kilometers, calculate the time at which the two trains pass each other. So they are asking what time that they will meet. We'll take T is the time taken to meet the two trains. So here, starting from here, within T minutes, T hours, because this is in hours, T hours, they will meet. So here also within T hours. So what's the distance here traveled? We don't know. But if you take distance traveled with the train A to B, this way, speed is given 60 kilometers per hour and the time is T hours. So what's the value? 60T. What's the distance traveled? The other train, B to A. Speed is 40 and taken T hours, 40T. We know the total distance is 100 kilometers. So we can form an equation. 60T plus 40T is equal to 100 kilometers. 60 plus 40, 100. T equals 100. T equals, divide by 100, you get 1 hour. So that means the train started at 8 o'clock in the morning. After 1 hour, they meet each other. So what's the time? We are asking, calculate the time at which the two trains pass each other. That's at 9 o'clock. 9 hours. Question number 10. Two motorcyclists who start their journey at the same instance from two different cities travel with uniform speeds of 40 and 50. So we'll take one traveler with 40 kilometers per hour, other one with 50 kilometers per hour towards each other. If they meet each other half an hour after commencing their journeys, so after half an hour, find the distance between the two cities. Now we know the speed and time. We can find out the distance traveled by this person. Speed into time. You get 20 kilometers. What about the other one? Distance traveled by the other person? 50 times half. You get 25 kilometers. So what's the total distance between the two cities? So the total distance is 20 plus 25, that's 45 kilometers. Now we'll look at how we can draw distance time graphs. So here we can find a pattern with the two variables there, distance and time. Now normally we take time in x-axis and distance as the y-axis. So when you draw the diagram with this method, distance in the y-axis and time is in the x-axis, we call this is the distance time graph. Now we'll look at this example in your textbook. One example is given. A table prepared with the information collected by observing the motion of a satellite traveling with uniform speed is given below. So time is 5, 10 like that in seconds. This one is distance in meters. So how we can represent this in distance time graph? So what we do, we take the two axes like that. Y-axis is distance and the x-axis is seconds. Then what you do, mark the units. Distance is in meters, time is in seconds. Then you can mark the point. 5 seconds, what's the distance? 100 meters. So 5, 100. So you mark the point. So what is the starting point? 0 distance, 0 seconds. So that's the starting point. Then you can mark the other points. 10 with 200, 10 with 200, then 15 with 300. So mark all the points and then connect it. That's called the distance time graph. So how can we find out the speed from this graph? So we take any 2 points. Now we'll take A and B. When you take A and B, what's the distance travel between A to B? This is 500 minus 300. That's the difference between these two. And what's the time taken for these two? This is 25 and 15. So what's the speed value? Speed is distance over time. So 500 minus 300 divide by 25 minus 15. So what's the answer? 200 over 10. You get 20 meters per second. Or you can read another point. Now somebody can take these two. These two. If you take these two, what's this distance? 700 minus 600. What's this one? 35 minus 30. Then what's the speed? Speed is 700 minus 600 is 100. Divide by 35 minus 30 is 5. Again you are getting 20 meters per second. So what can you say about the speed? Any time period here, the distance travelled within 1 unit time is a constant. Always 20 meters per second. So this is uniform speed. So we can say about this satellite, this travels within uniform motion. We'll take example number 1. A distance time graph illustrating the motion of Nimal, who cycled to his friend's house and then returned back home after spending some time with his friend, is given below. So this is the graph. Calculate the speed at which Nimal cycled to his friend's house. So here, starting from home, so this is the distance traveled to Nimal's friend's house. Now we want to calculate the speed. So what we do? We can find out the distance and divide by the time for traveling. So if you take this point and this point, A to B, what's the distance? So the distance traveled is this much. 6 kilometers minus 0. So 6 kilometers here. Then what's the time taken here to here? 30 minutes. So what's the speed? Speed A to B is 6 kilometers per 30 minutes. I'll convert this 30 to hours. What is 30 minutes means? Half an hour. So I can write 6 divided by half an hour. So 6 multiplied by 2 over 1, that's a reciprocal. You get 12 kilometers per hour for A to B. Then what about the speed at which Nimal returned home? So this is B to C is the time he spent with his friend. Nimal spent his time with his friend. So how many minutes? So 20 minutes he stayed there and then started to go home. So that is C to D. So C to D. When you take C to D, what's the speed? Here you can look at this graph. So point C to D, what's the distance traveled again? 12 minus 6. That means 6 kilometers. And how many minutes? 70 minus 50. So within 20 minutes, he traveled 6 kilometers. So what's the speed? 6 kilometers within 20 minutes. Now we can't use 20 minutes. So convert to hours. So 20 divided by 60 is number of hours. That means 1/3 hours. So we can do 6 divide by 1/3 hours, and that's 6 multiplied by 3/1, that's 18 kilometers per hour. So when he goes to his friend's house, he traveled with 12 kilometers per hour. Coming back home, that's 18 kilometers per hour. Exercise 22.2. The following table provides information on the distance traveled by car moving at a uniform speed along a highway, and the time taken for the journey is given. Hours and kilometers for distance. Draw a distance time graph with the above information. What's the first step? So we need to mark the two axes. So I can take this one as the distance and this one as the time. And I can write this is distance. What's the unit? Kilometers. And time in hours. Then I need to divide the scale. Now look at the values. When you take time 0 to 6, so that means we can take 1 square 1 hour. I can start with 0, 1, 2, 3, 4, 5, 6. And what about the other side? 0 to maximum is 360. So we need to divide this with how many squares we have? 1, 2, 3, 4, 5, 6. So we'll take 60 for 1 square. 60, 120, 180. When you add 60, 240, and then 300, 360. Now we can mark the points. Starting value 0, 0. Starting value 0, 0. I can mark the point here. 1 with 60. 1 hour, 60 kilometers. So I can mark the point here. 2 with 120. 2 with 120. 3 with 180. So I can mark 5 with 300 and 6 with 360. Then you need to connect the points. 4 with 240 is also there. Now take the ruler and connect. So we can start from here and connect these points. So that's the distance time graph. Now we'll try to answer the questions. Find the gradient of the graph. Gradient means same as speed. Gradient is the y distance divided by the x distance. So how can we do that? We can take any two readable points. I'll take the full graph. So what's the total distance traveled? 360. And what's the time? Within 6 hours. So I can find out the slope. I can find out the slope or gradient. (360) within 6 hours. So here, if you take this point and this point, the total distance is 360 within 6 units. So what's the speed? Or what's the gradient? 60. And hence, so this is second part, hence calculate the speed of the car. So when you take a straight line, the speed is the same as the slope of the line. Distance over time. So you can straight away write down, hence speed is equal to 60 kilometers per hour. Question number 2. The change in the distance with time of an object in motion is given in the following table. Time is given and the distance. Draw a distance time graph. So look at the two axes now. What are the two axes? You need to take time as the x-axis and this is as the y-axis. And then you have to scale it. When you want to scale it, look at the value. So starting value is 0. I can mark 0 here. Time 0, 2, 4, 6, 8, 10. So what's the maximum? Maximum is 10. So I can take 1 square is 2 units. 2, 4, 6, 8, 10. And what's the unit? Time is in seconds. What about the other one? Distance. Distance in meters. So 0 to 30. So I can take 1 square as 6. 6, 12, 18, 24, 30. That's the maximum. Now we can mark the points. 0, 0, that's this point. 2, 6, 4, 12, 6, 18, 8, 24 and 10, 30. Then what you do? You connect the points. So you get this straight line. That's the distance time graph. Now we'll try to answer the questions. Gradient of this graph. How can we find out the gradient? You can take any two readable points. I'll take here to here. The whole thing is 30 kilometers. So gradient is given 30 minus 0, that is 30. What's the total time? 10 minus 0. So 30 divided by 10, you get 3. So hence, what's the speed? Speed is same as the gradient. What's the unit? Meters per. Question number 3. A coach moving with uniform speed from the commencement of its journey travels a distance of 60 kilometers in 2 hours. If then travels another 40 kilometers in 2 hours, also with uniform speed and reaches its destination, represent the motion the coach in a distance time graph. So when you are drawing a distance time graph, what's the y-axis? Y-axis is the distance. And what's the x-axis? X-axis is the time. Now we'll label. This is distance and this is time. What's the unit? Distance in kilometers and time in hours. And read the question. It says 60 kilometers in 2 hours. So here we need to think about these distances 60 and 40. So that means 100 kilometers. We'll take 20 each. 20, 40, 60, 80, 100. Something like that. 20 represent 1 square. So it says 60 kilometers. That means starting point is 0 within 2 hours. So I'll take, this is 1, 2, 3, 4, 5, 6 like that. Within 2 hours travels 60 kilometers. So that means the first point is this, 2 hours 60 kilometers travel. Then another 40 kilometers in 2 hours. From here another 2 hours means 4. How many kilometers? 40. 60 plus 40, that's 100. So the next point is here. Now connect the points. Starting point is 0, 0. So I'll connect here to here first and then here to here. So in this graph, speeds are not equal. So this is the distance time graph. Now they ask, represent the motion in the coach in a distance time graph. So this is the distance time graph for the coach. Question number 4. A distance time graph of the motion of a man who travels from his home to the city on his motorcycle is given below. How far is it from his home to the city? When you look at this graph, this is home, starting point. Home to the city. So the full journey is to go to the city. So that means here to D. So what's the total distance? Look at this point, 6 kilometers. So we can take the total distance is 6 kilometers. Second part, how long did it take him to reach the city? Here to here. What's the time taken? 30 minutes. Calculate his average speed. So what's the average speed? Average speed is the total distance travelled divided by time for the travelling. So here always he travels. So what's the total distance? Total distance is 6 kilometers and time for travelling. So 6 kilometers divided by the time for travelling, that's here up to here 30 minutes. I can convert minutes to hours, that means half an hour. 6 kilometers divided by half an hour, I get 6 multiplied by 2, 12 kilometers per hour. That's the average speed. Separately calculate the speed at which he travelled from A to B, from B to C and C to D. Now we'll try to find out separately. A to B. A to B, that means this part. The distance travelled here is 3 minus 0 is 3. This is 10. 10 minutes. So you can convert to hours. Distance is 3 kilometers. Divide by 10 minutes, or you can write 10 over 60 to convert to hours. You get 1 over 6. 3 multiplied by 6, that means 18 kilometers per hour. So the speed A to B is 18 kilometers. Now we'll find B to C. B to C, refer the next one. Next part. What's the distance here? 5 minus 3. You get 2 here. And what's the time? 20 minus 10. That's also 10. You can write 2 kilometers within 10 minutes. Convert to hours, you divide by 60. So 2 times 6. You get 12 kilometers per hour. Then what about C to D? C to D, what's the distance traveled? Here, only 1 kilometer within 20 to 30, that's 10 minutes. So what's the speed? 1 kilometer divided by 10 minutes, convert to hours, 10 over 60. So 1 multiplied by 6 over 1, that's 6 kilometers per hour. Now we'll look at the relationship between volume and time. Now we'll take a certain pipe and water flows from this pipe, and if we can measure the amount of water comes from this pipe within a certain time, we can find out the rate of volume for this water flow. So what is rate of volume? Rate of volume is equal to the amount of water. So that means volume of water. Volume of water divided by the time taken to get this amount of volume. So this relationship is called rate of volume. Volume of water divided by time. So here, if you know the volume and time, we can find the rate. So what's the unit now? Now this is about volume. Volume we can measure using liters and time per second. So here liters per second. So what's the rate of volume? Liters per second. LS minus 1. Or you can measure with milliliters. How many milliliters for liter? 1000 milliliters for 1 liter. Or you can convert to cubic centimeters. What's the relationship between cubic centimeters and milliliters? So 1 milliliter is same as 1 cubic centimeters, and there's another important relationship. 1 cubic meter is 1000 liters. So you need to know this conversion when we are trying to find out the rate of volume. Look at the example number 1. The time taken for 30 liters of petrol to be pumped into a car through a pump at a certain petrol shed was 60 seconds. So 30 liters within 60 seconds. Find the rate at which petrol flows out of the pump. So rate of the volume. So we can find out the rate as the amount of amount of petrol, that's 30 liters within 60 seconds. So when you simplify, you get 0.5 liters per second. Or if you want this in milliliters per second, you can multiply by 1000. You get 500 milliliters per second. Example number 2. The length, breadth and height of cuboid shaped indoor water tank are, so this is a cuboid shape. Length is 2, breadth is 1.5 or 1.5, and height is 1 meter. So here we'll take this one as breadth and this is height. Height is 1 meter. On an occasion when the tank was completely filled with water, it took 50 minutes for the tank to be emptied by a pipe. Find the rate at which water flowed out through the pipe. Assume that the water flowed through the pipe uniformly. So what is the volume of the tank? This is a cuboid. That's length into breadth into height. 2 times 1.5 is 3 cubic meters now. Meters into meters into meters. Cubic meters. Then what you do? So we need to find out the rate at which the water flow through the pipe. So rate of change of volume with time is the volume divided by the time taken. So how many minutes taken? 50 minutes. So convert to hours. 50 minutes convert to hours, that's 5/6. So we'll do the calculation. 3 divided by 5/6 or 3 multiplied by 6/5. So 6 times 3, 18, divide by 5. What's the value? 5 times 3, 15. For 30, that's 6. What's the unit? This is in cubic meters and this is in within 1 hour. So cubic meters per hour. Example 3. A saline solution was administered to a patient at a rate of 0.2 milliliters per second. Calculate the time it takes for 450 milliliters of saline solution to be administered. Now, we know the rate of change of volume is volume over time. Now we need the time. When you cross multiply, you can make time as the subject of the formula. What is time? Volume divided by rate. We can use this formula to do this question. We know volume is 450 milliliters and the rate is given 0.2 milliliters per second. So we can find the answer in seconds. So you can multiply by 10 here. So that means multiply the numerator also by 10. 4,500 divided by 2. When you simplify, you get 2250 seconds. If you want to convert to hours, you can divide by 60 and by another 60. So convert to hours, 0, 0 and divide by 5. 5 times 1, 5 times 2, 5 times 4, 20. For 25, that's 5. 3 times 2, 3 times 15. Then again 3 times 5, 3 times 4. So what's the final one? 5/8. So 5/8 hours, or you can divide or you can now find out in minutes. Now this is a fraction, so it's better to convert to minutes. Multiply this by 60. You get the value in minutes. 2 times 4, 2 times 30, 2 times 2 again 15. 15 times 5, 75 divided by 2, you get 37.5 minutes for the time. Exercise 22.3. A cuboid-shaped tank built to provide water to housing scheme is of length 3 meters. So we'll mark it. 3 meters length, breadth is 2 meters and height is 1.5 meters. Calculate the volume of the tank. We know volume is length into breadth into height. So 6 times 1.5. So 1.5 I can write as 3 over 2 and 3 times 3, 9 cubic meters for the volume. Then the second part, how many liters is the volume equal to? Now the conversion. We know 1 cubic meter is 1000 liters. So 9 cubic meters means 9 into 1000. 9 into 1000 liters. So that's equal to 9000 liters. Part 3. How much time will it take to fill this tank completely using a pipe through which water flows at a uniform rate of 300 liters per minute? So here you're asked to find out the time. So what's the formula? Rate equals volume over time. So what is time? Volume over rate. We know the volume is 9000 liters and the rate is given as 300 liters per minute. So 0, 0 get cancelled out. 3 with this you get 30. So what's the answer? 30 minutes is the answer. Question number 2. If it took 40 minutes to completely fill a cube-shaped tank of side length 2 meters. So cube means all sides are equal. So 2, 2, 2. What is the rate at which water flows through the pipe in liters per minute? So hint is given, 1 cubic meter is 1000 liters. So you are asked to find out the rate. So what's the formula? Rate is volume divided by time. Volume is this one. So 2 times 2. That's in cubic meters and time is 40 minutes. Now you need to find out in liters. Liters, how you convert? This is 8. 8 cubic meters means how many liters? 8000 liters. Over 40 minutes, you get 200. So what's the rate? 200 liters per minute. Question number 3. How long will it take to fill a fish tank of length 80 centimeters, breadth 60 centimeters and height 40 centimeters using a pipe through which water flows at a uniform rate of 6 liters per minute? Hint is given, 1 cubic centimeter is 1 milliliter. So this is a cuboid shaped tank. So what's the volume? What's the length? Length is 80, breadth is 60 and height is 40. So what's the volume of the tank? 80 times 60 times 40 cubic centimeters. 48 times 4. 192 with 3 zeros. That's the volume. So how can we find out the rate? We need to find out the time now. Time is volume over rate. Volume of the tank is 192 and 3 zeros. Divide by rate is 6 liters per minute. Here this is in milliliters, this is in one is in milliliters and one is in liters. So here we'll divide this by 1000 to convert to liters, because 1000 milliliters is 1 liter. So 192 liters over 6 liters per minute. So divide 6 times 3, 18, 6 times 2. We get 32 minutes for this answer. Question number 4. The volume of a tank at a water distribution center is 1800 cubic meters. If water is distributed from this tank at a rate of 500 liters per second, how many minutes will it take to empty half the tank? No need to empty the full tank. So half the tank means, what's the volume? Volume is 1800 cubic meters. What's the half the tank means? Half of this amount. So we need 900 cubic centimeters to empty. Now, what's the time taken? Time taken, we need to find the rate is given this. So what's the time? Volume over rate. What's the volume you need to empty? 900 cubic meters. And what's the time? 500 liters per second. Now, you need to convert to liters. We know 1 cubic meter is 1000 liters. Convert to liters. This is 1000 into 900. And this is 500. So divide and you get 1800 seconds. So we'll convert to minutes. So minutes means you have to divide by 60. So 1800 divided by 60, you get 30 minutes. Question number 5. It took 40 minutes to fill an empty tank using a pump through which petrol flows at a uniform rate of 120 liters per minute. Find the capacity of the tank. So capacity is same as the volume. Now look at the question. Time is given 40 minutes. And this is 120 liters per minute is the rate. So we can find out the volume using other formula. Now we'll try to make volume as the subject. Rate is equal to volume over time. Now we need to find out volume. So what is volume? Volume is equal to rate into time. So we can make volume as the subject of the formula. So what's the volume here? Rate is given 120 liters per minute multiplied by time is given 40 minutes. So this one get cancelled out. You get 0, 0. 4 times 2, 8, 4 times 1, 4, 4800 liters. So that's the capacity of the tank. Miscellaneous exercise. A cylindrical water tank of cross-sectional area 0.5 square meters is filled to a height of 70 centimeters in 1 minute and 10 seconds by a pipe through which water flows at a uniform rate. Calculate the rate at which water flows out of the pipe. So this is a cylindrical shaped water tank. And it's given the cross-sectional area. So cross-sectional area is this, 0.5 square meters is filled to a height of 70 meters. So here this height is given 70 centimeters. Now we need to convert to meters. 70 divided by 100, or we can write 0.7 meters for the height. So what's the time taken to fill this up to this point? 1 minute and 10 seconds. So 1 minute and 10 seconds you can convert to seconds. 1 minute means 60 seconds and this 10 seconds altogether 70 seconds to fill the tank up to this point. So how can we find out the rate? Rate is volume over time. Volume is given in cubic meters. How can we find out volume of a cylinder? This is like a prism. If you know the cross-section area, area of the cross-section into height. So we can write 0.5 times 0.7 cubic centimeters is the volume. Then what's the time? 70 seconds. Now we'll convert to liters. 1 cubic meter is 1000 liters. Now when you multiply this one, 5 times 7, 35, and when you put 2 decimal places, 0.35. 0.35 cubic meters is 0.35 times 1000 liters over 70. So here when you multiply by 1000, you get 350 divided by 70. That's 5. What's the unit? 5 liters per second. Question number 2. The distance between railway stations X and Y is 420 kilometers. So we'll take XY, that's 420 kilometers. A train leaves station X at 7 p.m. and travels towards station Y with uniform speed 100 kilometers per hour. Now an hour later, so hour later, this one comes, so 8 p.m. this one starts and travel towards X with uniform speed 60 kilometers per hour. At what time do the two trains pass each other? So here we need to first find out the distance traveled between the distance travel for this train X to Y within 1 hour, because this train starts 1 hour later. So till 8 p.m. we need to find out the distance travel by this train X to Y. So what's the distance travel within 1 hour? Speed is 100 into 1 hour. So you get 100 kilometers travel. So what happens now? Now the new situation is 100 here. Then what's the other distance? The total distance is 420 minus 100. You get 320 kilometers now in between these two trains. Now assume that they meet T hours after this time. Here also T hours after this time. Then what's the distance traveled by this train? X to Y. The distance is, the speed is 100 and the time is T. So 100 T. What's the distance traveled Y to X direction? 60 times T, because the speed is 60 now. Now the total distance between those two trains is now 320 kilometers. So we can write down an equation. 100T plus 60T is equal to 320 kilometers. This is 160T is 320. So what is T value? So T is equal to 320 divided by 160. 0 get cancelled out. You get 2. So 2 hours for the time. Now what's the time then? So this is after 8 p.m. 2 hours after 8 p.m. is 10 p.m. now. So the time now is 10 p.m. So the two trains meet at 10 p.m. Question number 3. The railway station A and B are 300 kilometers apart. A certain train takes 12 hours to travel from A to B and then back to A. So here the total time taken is 12 hours and here 2 hours stayed at B. So that means what's the traveling time? So traveling time is 12 hours minus 2, that means 10 hours. So traveling time is 10 hours. So here what's the total distance traveled by the train? 300 here, another 300 there, altogether 600. So what's the speed of the train? You can find out the speed is, total distance traveled is 600 kilometers, divide by how many hours traveled? 10 hours. So when you simplify, you get 60 kilometers per hour. So both trains, the speeds are the same. So that's 60 kilometers per hour. Now look at the other one. Another train leaves station A 10 hours after the first train. Now when you take the distance from A to B, now here earlier 10 hours traveling both ways. So that means 5 hours one way, the other 5 hours the other way. Now 5 hours here and resting time 2 hours. Altogether 7 hours. So within 10 hours, how many hours he can travel? So 5 plus 2, 7 and 10 minus 7. So this train can travel only another 3 hours there. So what's the distance traveled by that train? About 3 hours. So we can find out distance traveled for 3 hours. Speed is 60 and hours is 3. So 180 kilometers traveled. Now look at the diagram. Altogether 300 kilometers are there, and now this train traveled 180 80 kilometers. So what is the remaining distance? The total distance is 300. 300 minus 180. You get 120 kilometers. So this distance is 120 kilometers. Now, this train starts at the same speed, so 60 kilometers per hour, and this train also comes with 60 kilometers per hour. Because the two trains has the same speed, so they need to meet in the midpoint of these two. So 120, what's the midpoint? 60 kilometers and 60 kilometers. So this distance is 60 kilometers and this distance is 60 kilometers. Now what was the question? Question asked, how far has the second train travelled when the two trains pass each other? So that means when the two trains comes here, this distance, they are asking what's the other train travels? What's the distance other train travel? So this train, the second train travels 60 kilometers. And what about the first train? 300 plus 180 plus 60. So which train they ask? How far has the second train traveled when the two trains pass each other? So only the second train, that's only 60 kilometers. So in this lesson, we discussed about speed and also distance time graphs and the relationship between volume and time. That's the rate of change of volume. So apply the formulae correctly when you want to find out the rates.